Okay, so this first video is going to be about the periodic table. And so if you've ever seen it, it looks something like probably looks something like this if you've ever seen it. Although I can't guarantee that you've seen it. If you're in middle school, high school, you've seen it. In lower school, I can't guarantee that you've seen it. But it looks something like this, kind of. And there we go, that's better. Wait, no. Okay, yeah, there. That's better. So most people have probably seen this. And so it consists of all 118 elements that make up the world. I guess I should technically be saying 96, but yeah. So the first thing you see is a bunch of numbers and a bunch of letters and a bunch of colors. Because, that's pretty much what it is. So, the first thing to take in here is these, well, it's not going to be the first thing you notice, but first thing to take in is these numbers up here, that go 1 to 18, all the way along here up at the top. And those are the groups. So the groups are vertical, so like the first group includes hydrogen, lithium, sodium, potassium, rubidium, cesium, and francium. And these normally have something to do with each other. Like this row, the first row, they all have something to do with each other. They're all the alkali metals, except for hydrogen. And then it goes to the alkali earth, and then you have all the transition metals and halogens and noble gases on the other side. So yeah. And then you have your periods, which go horizontal. There's 7. They start with hydrogen, and then lithium, and then sodium, potassium, rubidium, cesium, and francium. And they go across, and the periods are always longer than the groups, with the exception of the first period with hydrogen and helium, because, well, they're kind of like loners, I guess you could say. Because hydrogen doesn't really fit into a group, it's just like by itself. So some people I'm getting ahead of myself. Okay. The next thing to notice is the letters on each little box, and the fact that there's 118 of the boxes. So the letter is the symbol for the element, and this is used to write it down quicker because people don't want to write down praseodymium every time they need to write it. Instead, they just write PR. So, yeah. And then you have this number on the top left. So, like hydrogen, it says 1. Helium, it says 2. Like neon, it says 10. Arsenic, it says 33. So, yeah, stuff like that. And so, these are the number of protons in the... This is the number of protons in the atom. So, an atom is the smallest part of an element that still has the characteristics of that element. And protons are a particle in an atom, and, well, that's all you need to know for now. So, that's that. And then you see the name below the symbol. So, like, Fe is iron, because its Latin or Greek name is ferrum. Like, sodium is Na, natrium. Tungsten is W for wolfram. So, yeah. And then you see this string of random numbers at the bottom. Hydrogen, it says 1.008. Thallium, it says 204.383. So this is the atomic mass of the element in... I don't know what it's in. So the way that they figure out this number is, so the most common isotope, the most common form of hydrogen is hydrogen, like hydrogen 1. It's the simplest atom. It has a neutron and an electron. Simplest atom, so the electrons don't count towards the mass, and a proton and a neutron are both worth 1. So you have an atomic mass of 1 for hydrogen 1, but there's also hydrogen-2 deuterium, and hydrogen-3 tritium. So they kind of like take the average of these, and that's the atomic mass. So like that's how they have such random numbers. Then you look down here and you see like, we'll take 99, Einsteinium for example. It has 254 in brackets. So that is because these elements are man-made. They do not occur naturally. And so the weight of them isn't exact. The mass of them isn't exact. And they've rarely been created. And then some say unknown, like the last one, Oganesson, tennessine, moscovium, nihonium. I think those are the only ones. And that's because they're so hard to get. I think 3 atoms of Oganesson have ever been produced, and it cost billions of dollars. So the last thing to take in here, 2 more things. One, right here, right next to barium and radium, there's a break, and it matches up with these elements at the bottom. I don't know that you can see my cursor. I really hope you can. So these ones are the Lanthanides and the Actinides. So the Lanthanides match up with barium 57 through 71, and the Actinides match up with the 89 through 103 next to radium. So the reason why these are down here is because Dimitri Mendeleev decided that these, if we put these there, they wouldn't fit on the periodic table no longer fit on a single piece of paper. So instead they just put them down there. I don't know why they put them down there, but they did. Okay, now finally the last thing. Down here on the bottom it has a bunch of colors with names. Alkali metal, alkaline earth, transition metals, basic metals, semi-metals, non-metals, halogens, noble gases, lanthanides, and actinides. So these color code to the groups, and the groups have something similar with each other. So like the alkali metals react aggressively with stuff like water. You may have seen this, people dropping sodium in water, it causes it to explode. The alkaline earth are the same thing, they just are a little bit less reactive. And the thing though is hydrogen is not an alkali metal, because one, it's not a metal, and it shares none of the characteristics of it. And then there's the transition metals, which are a bunch of metals. There's the basic metals, which include stuff like aluminum, tin, lead, bismuth, and some of these radioactive ones. So this last row from rutherfordium, number 104, right next to the actinides on, these are kind of like their own category. So there's the basic metals, which are these green ones. There's the semi-metals, which include stuff like boron and silicon, arsenic, if you've heard of that, polonium, most people have heard of that. And then there's the non-metals, which includes gases like carbon, nitrogen, oxygen, and includes sulfur and hydrogen, which is kind of just like over here, is completely separated. There's the halogens, which react extremely aggressively with the alkali metals. And in fact, fluorine, number 9 at the top, is the most reactive element. And then there's the noble gases at the end, which do nothing. Absolutely nothing. They don't like to react at all. So that's the periodic table. And so yeah, that's the periodic table. So, oh my god. So yeah, periodic table. So it was created by Dimitri Mendeleev, that is spelled like this, Mendeleev. No, like that. Let me zoom. No. Dimitri Mendeleev. Okay. It is spelled like that. Yeah, like that. Dimitri Mendeleev. It's not Dimitri Mendeleev, it's Dimitri Mendeleev. He was a Russian scientist. He lived in the 19th century. He invented the periodic table in 1866. He is normally credited with the invention of the periodic table, but not really, because other people made it before him, but he was one of the first to realize that the atomic masses of the elements don't have to go in order. An example of this is cobalt and nickel, 27 and 28 in the 9th and 10th groups. Cobalt has a mass of 58.933, and nickel has a mass of 58.693. Maybe a small difference, but it's still a difference. Dimitri was one of the first people to realize this, and so yeah. He has a tragic life story. He grew up, his father died when he was very young, and then his mother and their 5 children opened up a glass factory, and then a year later it burnt down, and then Dimitri went to college, and he rode 500 miles on horseback and got rejected, and then he rode another 200 miles and got accepted, and then his mother died. And then he just worked and worked and worked and worked. And the funny thing is, Dimitri Mendeleev, he predicted the properties of the elements. He predicted that there were holes in the periodic table for elements that hadn't yet been discovered. So this French scientist came along, and he was like, ooh, I discovered one of these elements, and here are the properties of it. And Dimitri was like, no, it's not an actual element. You didn't discover anything because they don't it doesn't match up with the properties. He said, you're wrong. I'm right. And Dimitri had never seen this element. And turns out he was right. Yeah, that's how confident he was in himself. And so, yeah, there are a couple versions of the periodic table because this is one of them that was proposed. This thing. I don't know. I don't. I don't really know. But yeah. There are some periodic tables that look like this. And that is what I'm talking about. Those Lanthanides and Actinides are now added in, and that makes this very long. So, yeah. And then, of course, there's this one. I'm not really sure what that was. Why does it go to 168? That's 50 elements over. What? And they're not even categorized. What the heck? Huh. That doesn't make any sense. Oh, I see what they did. See, the elements have gone through different naming stages, and so hasium metranium is 109. Ununtrium is 110. It's 110. Untrium is 111 because 111. Bententium, I don't know, 112. Tritium, 113. Quadium, 114. Pentium, 115. Hexium, 116. Septium, 118. Octium, 118. And I see what they did. They just continued that pattern on. Ugh. I don't know what any of these are. But yeah, they just continue that pattern on. Let me zoom out. So, yeah. So that's a brief history of the periodic table for you, and I hope you enjoyed this video. I don't know how well of a demonstration of the periodic table that is. It may have been a little confusing. It may have been a little fast. I may talk too fast. I probably do. But, yeah. I hope you liked it. Oh, wait. I forgot something. I can draw all over this. So, I could have just, showed you what I was talking about. I think I'll do that next time. Oh, yes. If you didn't know my name, well, of course you didn't know because I didn't say it, but my name is Jackson. And let's see. I'm drawing with this with a mouse pad, so it's really bad. Jackson. Yay. Okay. I hope you enjoyed this video, and please like and subscribe, and thank you for watching. Goodbye.